Hi, geometry students. Making stains. So I'm going to go through 946 notes. We did a little bit of these notes. We learned 94 and 95, which were tangent and sine, cosine. Just a quick review: if we have a right triangle, acute angles theta, and the sine of theta, we do the opposite hypotenuse over that is the third side is the adjacent side. The adjacent side, but it's not the hypotenuse. Cosine is the adjacent. Is used TOA. If you want to hear a notes. Today we're going to learn how to solve. And we're going to use angle. Given acute angle and a given. So in these examples, this is going to be, this method here we're going to do is to use the missing side length. Angle. So in this picture, the given acute angle is 32 degrees. It's not so much about knowing that it's 11 and x, it's more about sides those are according to this angle. So according to the degrees, the 11 is the opposite. According to the 30, so if I have the opposite and adjacent out, so TOA ratio, tangent that I know from this triangle, the tangent of theta is 32 degrees, is equal to the opposite, which is adjacent, which I don't know. That's x. So what we're going to do is we're going to solve an equation. We're going to get, we have one side. I'm actually going to make this side into a fraction. I'm going to put it over 1. Multiply. The order of x, tangent 32 degrees. 1 times 11, which is 11. Now to sides by tangent 32 degrees. That's going to give 7 divided by 32 degrees. So now we can find this tangent 30, not something that I know, so I'm going to have to use my calculator. It will go your calculator answer. First thing before you do anything, make sure that you go right here, and this needs to be. There is something called radian mode, which we'll learn about later, but we need this angle that is in 30. Mine's not in degree mode anymore. All you need to do is arrow over to the degree and then hit mode. From here, once it's in degree mode, if you just hit if you have an old calculator, it doesn't really matter. You can just do divide, and then there's a tangent button right there, tangent, and then that's 32. Enter, and we get an answer. It's about 17 points, and that's the length of that side, 17.6. And say, well, this is 11, and this one looks like it's a longer side, so does 17. I got an answer like 2. All right, in question B, we have 2 missing sides, so we're going to do this 2 different times. I'm going to start with angle, 26 degrees. That and missing side, I'll just start with x first. And according to 26 degrees, x is the opposite. So we're going to do the sine of theta, the opposite over the hypotenuse. Now go ahead and plug the sine of 26 degrees is equal to the hypotenuse over 1 is x, and then 14 times 4 times sine 26. Here. 14 sine 26. So if you put that number you're multiplying in front of differently, then you might get some answers wrong unless you correctly put them in your calculator. 6.137, 6.1. All right, and then the second part, we're going to do the angle, same one, 26. Is our adjacent. So using adjacent is to the cosine of 26 is equal to cosine y is by itself. I'm going to my calculator. 14 sine 26. 12.6. 12.58, approximately 12.6. All right, so there is a third one. I would encourage you to pause your video and try this one on your own. After you think you've got it, restart your video. If you get stuck somewhere along the way, restart the video, get to the part where watch me get you through that part, then pause it again. See. So acute angle. Acute angle is 65 degrees. Given side T and a U. I'll just go with T first. And according to the 65, that is tangent. Tangent of theta is the my information in. Tangent of 26. Nope. even using my tangent of 65, the opposite, which is t, over 1, and I'm going to cross multiply. T times 1 is 8 tangent . All right, and then the second part, the acute angle is 65 degrees. The given side is still 8, which is the adjacent, which is the hypotenuse. This is adjacent and hypotenuse. That is cosine. Cosine of the hypotenuse. Cosine of 65 degrees is equal to, which is u. The cosine of 65 degrees over 1 times cosine 65 equals 8 times. We need to get u itself. 65. Divide by cosine 65 degrees. 8. We're going to do missing side when we in one side of any right. Okay, the next section, inverse. I'm going to use this word inverse a few times. So just talking about inverses before. That plus 5 equals 17, and I wanted to undo the plus 5, you of addition would do subtraction to both sides so that we could find that x equals 12. Here is inverse. Using subtraction. So if we had a like 3x equals, solve for x times x, and we want to use the inverse of that, you would use division. Let's multiply and divide. Those are inverse. So we have x equals 10/3 by using the like if I've got x squared, as would tell me, oh, you need to square root. And I would say, yep, and you also have to put in a plus minus. Square root, we have to put in a plus minus. You'd actually get two answers. A plus minus and square root of 25 is 5. But again, square root and squares, those are inverse operations. They undo each other. That's how we get x by itself. Use the inverse trig operation. We're going to use an inverse trig. So here, let angle A for inverse tangent. The symbol for inverse tangent looks like that. So anytime you want to you have to use inverse tangent. Inverse sine and we will be using our calculator for these. So I'm going to solve this equation, and to solve this equation, and I look for a variable a, and for of n is what I'm finding. I'm finding the measurement of an angle, and up here, here's another hint, angle. To cancel out tangent, but you cannot divide tangent. Tangent's not something that's being multiplied. It is a ratio of sides. To undo the ratio of sides, you have to use inverse tangent. So we're going to do that to both sides of the equation. Inverse tangent to tangent A. I didn't write to 0.75. So we're doing that to both sides of the equation. When you do inverse tangent, out. On the other side, I still have tangent inverse of 0. We have the variable over here. All I have to do is simplify this side, but I can't do this without a calculator, and neither can you. So this is a calculator problem. You can see right above tangent is its inverse tangent. Right above it, so we're going to do second inverse tangent. So this angle is approximately 30 degrees. So it is approximately 36 point. So that for this time. So sine B equals 0.8. I have to undo sine B by is sine. We have to do first of A equals, we have to do it to the other side, sine inverse of 0.8. So sine inverse, and on the other side we have sine inverse 0.87. Calculator, second sine degrees. 5 degrees. If you think you got this, I cosine C. You can keep watching, but if you watching the video to see if you got it right. Cosine, so I'm going to do it to both sides. So cosine inverse of cosine inverse and the cosine, we get C is equal to cosine. For my calculator, I'm going to do second cosine approximately 81.4 degrees. If you set it to degrees calculator and you don't like restart your calculator, and then make sure, well, that's for the next thing. Okay. Almost. We're going to use the inverse trig that I just taught you. We're going to use the inverse trig. There. Side is 12. According to theta, 12 is opposite. Actually, triangle 17 is hypotenuse. Hypotenuse, I'm going to need is equal to the opposite over the hypotenuse. Again, we have to know SOHCAHTOA because that's how we remember ratios. So now I'm going to plug in the. I know. I do not know theta. That's what I'm going to solve for. This is 17. So we need to cancel out sine. So we need inverse sine to both sides. So I'm going to have inverse to sine theta equals inverse sine undoes sine, and we have theta equals 17. Sine 12 divided by 17. 44.9 degrees. If you think you got it, pause. To find that angle. Given it has to be the adjacent side, and 5 opposite is equal to opposite over adjacent. Tangent, the 5, the adjacent. Now we need to undo tangent, so we're going to do inverse tangent. All right, so that's just the tangent, and we will have alpha left over, and I need to type into my calculator. Tangent 5 divided by 3, get 59 degrees. If you think you got it, pause the video right now. Try question C by yourself. Pause the video. You can check to make sure you did it correct. Pause the video. Okay, there's a question mark. I need to the angle adjacent side. 35 is the hypotenuse. Theta the adjacent over the hypotenuse. So I'm going to plug in the information that see 32 over do inverse cosine of cosine 32 over 35. So question mark is equal to inverse cosine second cosine divided by 35, approximately 0.9 degrees. Hope you're doing okay so far. Just at home. So or 30, 60, 90 triangle. We're going to use the proportions to fill out the sides. By proportions is like the formula. That's 30, 60, 90. My shortest side is across from the 30 degrees, and we were calling that which one? That one was just a variable. And then the longest side was 2a, the hypotenuse, remember? Hypotenuse has the 2 in it. And then the third side is a radical 3. And because this is a special right triangle, it always, always, always has so usually us mathletes, we like to pick the easiest number we can put in for A, and we choose 1. So if I make A 1 equals 1, then I'm actually going to use 1, 2, and then 1 times square root of 3 is square root 3. So I'm going to use the pink values. You're more than welcome to use variable N, but if answers will come out the same because they're all the ratio of the all 30, 60, 90 degrees triangles are same. Always have that. Okay, we need to find the tangent of 60 degrees. Tangent is the opposite over the adjacent. Tangent of 60 is where we're, and the hypotenuse is 2. That does not reduce. We have a square root degrees. So we're going to do the same thing again. We're going to use the pattern. We're going to use it when it equals 8. And across from 60 is going to be the square root. degrees, I'm going to go opposite of 30. Is 1/2. And then using easy numbers. So if this is 1, then this one is also 1. Is equal to adjacent over hypotenuse. 1 second. 45 degrees. So actually, there's two 45 degrees. So if I do adjacent one, the answer is 1. So it does not matter which 45 degrees we choose. Break, we had situations like this where you are not allowed to leave a square root in the denominator. So we are going to multiply by square root of 2 over square root of 2, so that and the numerator 1 times square root of 2 is just square root 2. If I square a summation, they undo each other. We the square root of 2 on top, and on the bottom we get just a 2. 45 degrees. Any other kind of triangle, you're going to use your calculator. We do not use our calculator. Maybe I should make that very obvious. And all right, the very oh, 30, 60, 90, and we across from 30 degrees is the 2a, and the third side is a square root 3. So if I know is equal to 10 square root 21, I can when you are not under the radical, and reduce them. So I can reduce the 10 and the 2. 5 square root 21 is the a. So up here, the short side is 5. To find the third side, we have to take a, which is this number right here, and we have to multiply. 3 is taking, I can multiply things that are in the same location. I can multiply the square root of 21 and the square. So 5, and there's still a square root, 21 times 3. What is this? So, 63. I always want to check and make sure square root can redo. 63 is the same thing as 9 times 7. So if I break the square root of 9 simplifies to 3.